Hello everyone, myself Monica Chaudhary from IT Department, AITR Indore, and my today's topic is hill climbing algorithm. Now, what is hill climbing algorithm and why we should use the algorithm and when we have to use the algorithm? Now, the first point, this is a type of the local search algorithm, means it will search the area around the surrounding and it will give us the maximum value from that local search. And it is also known as the type of the heuristic search algorithm. The meaning of the heuristic means we have some previous knowledge and previous data, and by using that data we have to move forward. Now, hill climbing algorithm is a local search algorithm which continuously move in the direction of increasing elevation value to find the peak of the mountain or the best solution of the problem. It terminates when it reaches a peak value or no neighbor has a higher value. Means local search. It will search around the surroundings. Hill climbing algorithm is a technique which is used to optimizing the mathematical problem. One of the widely discussed example of the hill climbing algorithm is traveling salesman problem. Traveling salesman means we have to find the shortest or nearest path by minimizing our cost, which we need to minimize the distance traveled by the salesman. It is also called greedy local search as it only look it to good immediate neighbor state, not beyond that. Our whole hill climbing algorithm is the basic on the foundation of the local search, means it will search around the neighbors surrounding, it will not look far or backtrack. Node of hill climbing algorithm has two components which are state and value. State means at which position we are, and value is the heuristic value which is available on that state. And the one of the major step to move forward is that our next value must be greater than or equal to the previous one. If we are already on the greater value, then we will not move forward. Hill climbing is mostly used when a good heuristic is available. Heuristic meaning is means we have some predefined knowledge or data on that state. In this algorithm, we don't need to maintain the handle or search tree or a graph. It only gives a single current state. Now, how the algorithm for the simple hill climbing work? First, it evaluates the initial state. If it is goal state, return success. Second, make the initial state the current state. Loop until a solution is found or no operator can be applied. Select a new state which has not yet been applied to the current state. Evaluate the new state. If the new state is goal state, then return success. If the new state improve upon the current state, make it current state and continue. If it doesn't improve, continue searching neighboring states. Exit the function if no better state is found. Means we have some values and among them we have to find the better one than the current. If we don't find the better, then we will remain on the previous one. Feature of hill climbing algorithm: generate and test variant. For hill climbing is the variant of generate and test method. Generate and test method produce feedback which help to decide which direction move in the search space. Greedy approach: hill climbing algorithm search move in the direction which optimize the cost. No backtracking means if we move forward, then there is no option to go in the back. We have to move only if we have the better state than the current. Means our previous one obviously less than the current, then we will not move backward and no backtracking. Deterministic nature: heuristic climbing is deterministic optimization algorithm. Means that given the same initial condition and the same problem, it will always produce the same result. There is no randomness or uncertainty in its operation. Next is the local neighborhood. The hill climbing is a technique that operates within a small area around the current solution. It explores solutions that are closely related to the current state by making small gradual changes. This approach allowed to find a solution that is better than the current one, although it may be a global optimum. Next, advantages of the hill climbing algorithm. The first one, the first part of the paper is based on the hill climbing diagram that can easily put things together, ideal for the complex optimization problem. Second, it uses less RAM for the current problem state and the solution located around it. Then it comparing the algorithm for a tree search method which will require inspecting and the entire tree. Consequently, reducing the total memory resources to be used. Space is what matter solution should occupy in a convenient area to consume a little of memory as possible. When it comes to the acceleration of the hill climbing up, most of time it bring a closer in the local maximum straight away. This is the route if we having quickly getting a solution outshining acquiring a global maximum in an instant. Now the advantage means we will get the optimal solution. We will not get an randomization. If again we will use the same algo, then we will get the same solution. This is the optimal and the greedy solution also. Next, the different region in the state space landscape. The first one is the local maximum. As all of you are, the graph is visible to you here. The mean means we have some value in our surrounding. It may be maximum from the surrounding, but it may not be best and the bigger in all values. Means it not a global maximum. It is the local maximum. It is maximum value within the given set. It may be a less value if we compare with the whole set or other set. Now, the local maximum is the state which is better than its neighbor state, but there is also another state which is higher than it. Now, next one is the global maximum. Global maximum is the best possible state of the state space landscape. Means it has the highest value of the objective function. Current state. It is state in the landscape diagram where an agent is currently present. Current state means at present but we are on the which state. Flat local maximum. It is the flat space in the landscape where all the neighbor state of the current state have the same value. Means we are unable to find the better one value for the few steps we have the same value. Means flat local maximum. There is no change in the current and previous one. Next one is the shoulder. It is the plateau region which is an uphill edge. Now the different regions may be local maximum, global maximum, current state, flat and shoulder. There are some problem in the hill climbing algorithm. The first one is the local maximum. Local maximum means our value may be good in the neighbor but not best among the all. Means local maximum is a peak state in the land space which is better than each of its neighboring state. But there is another state also present which is higher than the local maximum. Means this is the maximum value within the local area. It is not the highest or the best or better value around the whole set. Solution of this problem is backtracking, which is practically not possible because I have started the hill climbing algorithm with the one concept that our algorithm will start. Our algorithm will start if we move from the better position. Next one is the plateau. Plateau is a flat area of search space in which all the neighbor state of the current state contain the same value. Means because of this algorithm doesn't find any best direction to move. There is no better state and hill climbing search algorithm might be lost in the plateau area. The solution for the plateau is to take the big step or very little step while searching. To solve the problem, randomly select a state which is far away from the current state so it is possible that algorithm could find no plateau region. Plateau means our next state is not better than the previous one. We are on the same step. And the solution of this problem is, if you make a big jump, this is also not possible in real life. Next one is the ridge. Ridge is a special form of local maximum. It has an area which is higher than its surrounding area, but itself has a slope and cannot be reached in a single move. Solution: with the use of bidirectional search or by moving in different direction, we can improve this problem. Next is the application of the hill climbing in AI. Pathfinding, uh, traveling salesman's problem, optimization. We will optimize the result. Game AI. In certain games, AI uses hill climbing to elevate, improve its position relevant to its opponent. Machine learning means we can train our machine according to the given data set and it will work accordingly. Thank you.